Hello everyone, this is Professor Vishal Gupta with BUAD 311 at the USC Marshall School of Business. So this is a short video I promised you guys, finishing up the last example that we did in our lecture on capacity control that I got to finish in some of my classes but not others. So just as a reminder, what's the example? We're thinking about an airplane that has 150 seats. And we're going to engage in some dynamic pricing. So early bird prices are going to be $200. The late price for people who come last minute is going to be $300. And the question tells us that the demand for high willingness to pay or late customers is equally likely to be anywhere between 51 and 70. Now we talked about this a little bit in class, but just as a reminder, what does this mean? This is the discrete uniform distribution on the numbers between 51 and 70 inclusive. Okay, so how many numbers are there between 51 and 70? You should convince yourself that there are 20 numbers if I include 51 and 70, between 51 and 70. So students sometimes get confused about this, but remember, if I want to know how many numbers are between 2 and 5 inclusive, I can count them on my fingers. It's 2, 3, 4, 5. That's 4 numbers. And the way that I do that is I do 5 minus 2 plus 1. So how many numbers are between 51 and 70? It's 70 minus 51 plus 1. There's 20 numbers. All right, so the other way to think about this demand, which might be helpful to you, is think about it like rolling a 20-sided die. So you roll this die, it's equally likely to come up on any face. Each of the faces say the numbers between 51 to 70. All right, and the question first says, suppose we've already sold 90 seats to early customers. Should we reserve the 91st seat for a late booking customer? All right, so I'm going to think about this. I'm going to do this using the same sort of marginal analysis we've been using in class. So in particular, I want to think about, I've sold my 90 seats, and I'm thinking about what to do when the next customer comes up. Now in the back of my head, I just want to think, okay, the plane was of size 150, and I've sold 90 seats, so really there are 60 seats remaining. Okay, let's just put that piece of information in the back of our heads. All right, and now I've sold my 90 seats, the 91st customer comes up, I have a decision to make. I could sell to him right now, and if I sell to him right now, I guess I get the low price, which was $200. Or I could say, I'm not going to sell to him right now. I'm going to reserve this seat. And I'm going to think about what would happen in the future. And if I'm lucky in the future, I'll be able to fill this seat with a high willingness to pay customer, in which case I'll get $300. And if I'm unlucky, I won't be able to fill the seat and I'll get $0. So far, this should be pretty simple. All right, now I just only have to think about what is the probability of this good thing happening, of me getting this $300. Well, if we think about it, there are 60 seats remaining in the plane, right? So this is the plane. I've sold these seats. There are 60 seats up here, and I'm thinking about this last seat over here. Right, this is the one that I'm thinking about selling or reserving. And I'm thinking about the marginal value of this seat. So in particular, the marginal value of saving this seat versus selling it and starting to save from the next seat. You can convince yourself that if I have to put a button in this seat, the only way I'm going to be able to do that is if the number of people that come in the next period is at least 60. And so in particular, this side is also DH less than 60. Okay, I can turn that decision tree into a little rule. I can think about what is the expected value at this node. This is, I guess, 300 times the probability that the demand is greater than or equal to 60. And this is 0 times this thing, so I won't bother writing it. And I get this little rule. Reserve 60th remaining seat. if 300 times the probability that the demand is at least 60 is bigger than 200. And why 200? Because 200 is what I would get if I chose not to sell it. All right, I can divide both of these sides by 300 just to make things a little bit simpler. This rule is the same as saying I should reserve the 60th seat if the high demand, being probability that the high demand is at least 60 is at least 200 over 300, which is 2/3. Okay, so now I just have to figure out what is this probability. So I'm going to think about my die. Remember my 20-sided die. So each of those, there's 20 sides to the die. They're each equally likely to come up. How many sides are good sides? The number of sides where this works is any number like 60, 61, 62, all the way up to 70. How many numbers are here? This is equal to 70 minus 60 plus 1. Remember, because I'm including the 60. So this is 11. So I get 11 out of 20, which is 0.55. Right, and then if I compare to here, let me erase some of this scratch work. I would say reserve if 0.55 is greater than 2/3, which is like 0.66. This is not true, so I should sell the seat. Okay, and so that's the first part of the question. Now, if I want to think about the second part of the question, which asks how many seats should I reserve, or what is the booking limit, I could just proceed iteratively. I know that I should sell this seat, and now I could ask, okay, do I sell this one, and move forward, and then we could check about the next one, etc. That's going to be a little bit painful. If I look at this directly, though, I can convince myself that for whatever seat I'm looking at here, this tree is exactly the same. The only thing that changes in the tree is this 60. So, what I could write is I could write a generic rule that says reserve the nth remaining seat if, and then I look back here, what would it be? It would be this probability, but I would change the 60. So it would be probability that DH is greater than or equal to, not 60, that's what I had before, but S greater than, and I see here, 2/3. Okay, now in the examples we did in class, this probability we could figure out directly from the tables, right? We made that yellow column, we added things up, and we scanned through the table. Here I don't have a table, so I could make one. I could say, all right, the demand is equally likely to be any number between 51 and 70. So it could be 51, 52, 53, all the way down to 70. It's equally likely there's 20 numbers, so I guess this has probability 0.05, this has probability 0.05, this has probability 0.05, all the way down. And then you could start adding up to see what is the probability of greater than or equal to S. Let's give that a little bit more room. This would be 1, because I would add up all the numbers going down. This would be 0.95 because I would add up these numbers going down. The next one would be 0.9, etc. Again, like we could do this, but this is going to be pretty painful still. So let me think if I can do something even a little bit smarter than this table. And looking at this example, I remember that this is a 20-sided die, so I could actually compute this number exactly. So I could say, hey, there's 20 sides on the die. They're all equally likely, so that's out of 20. How many of them are bigger than S, inclusive, greater than or equal to S? I would do 70 minus S plus 1. So again, my rule then becomes, okay, reserve the S seat if 70 minus S plus 1 is greater than 2/3. And now I can try to solve for S, right? So I would multiply by the 20 on both sides. So I'm going to get 71 minus S is greater than 2/3 times 20, which is 40/3. And then we're going to put the S on, I'm going to put the S on this side, the 40/3 on this side. So I get 71 minus 40/3 is greater than S. And then this number ends up being 57.67. Okay, so if S is less than 57.67, I reserve. And if S is bigger than 57.67, I would sell. So I'm going to reserve the 57th seat. Sorry, let me be more clear about that. I'm going to reserve the 57th remaining seat. Because remember, S was the S remaining seat. Okay, so how many tickets do I sell then? Well, there was 150 seats on the plane, minus the 57 that I'm going to reserve, and that means I should sell 93. So 93 is the booking limit. Okay, if you have any questions about this, please do let me know. Come to class and ask me, or send me an email, or come to office hours and I'll happily work through it. Otherwise, I will see you soon in class. Have a great weekend.